Hello, my name is Sean Ditchko and welcome to the fourth video in our series on using spreadsheets. We're going to pick up where we left off in video 3, where we made a best fit line visually. And this time we're going to use some spreadsheet functions and chi-squared analysis to create the best fit line for us. Then I'm going to introduce this chi-square formula and also compare that with the built-in trendline functions that are part of OpenOffice Calc, and then show a fit to assign function, which is something that the built-in trendline functions cannot do, and we're going to do this using chi-squared analysis. This formula chi-square represents how far the fit is from the data. It's not important to us how this formula is derived. You could ask a statistician for that explanation. What's important to us is how this formula behaves and why it's useful. Let's look at this graph down here and see how each of the terms in our formula actually is represented on the graph. You can see here the third data point. This would be the V fit. This would be the value of the fit at the third data point, and this subscript I is representing the ith data point, third one in this case. And then here is the value of the measured data. This data point has an error bar, and that is represented by sigma 3. The numerator of the chi-square equation is this difference between the fit and the measured data point. This difference is squared so that the difference is always positive. So it doesn't matter whether the data point is below the fit or whether it's above the fit, as in this case. In this equation, we're also dividing by the error. And this is useful only if the error is different for the different data points. The reason for doing this is to give more weight to points that have less error. You can imagine that if this point here had lots of error, well then, if the fit is some distance away from that point, as here, that difference won't matter as much since the error is so big in that data point. In this equation, we'll end up dividing that difference by a large denominator since the error is large. And so this particular difference won't contribute as much to the total. On the other hand, the difference here is significant because the error in this particular data point is so low, so the fit should get closer to this data point. And that will be reflected in the equation because we'll be dividing by a small number. For some reason, we square this error to make the weighting effect even more pronounced. Then you take all of these differences squared divided by the error in the data point squared, and you sum all the results between every data point and the fit at that data point. And this total is called chi-square. Let's go over to our spreadsheet. Let's type in the formula. It's going to be cell C2, put that in brackets, minus D2 all squared divided by the standard deviation, which is $J$2, because I want to make that an absolute cell reference, squared. And we'll copy that difference down the column. Now it's the total that we're interested in, so let's sum up all of these cells, E2 to E32. At this point, you have to install the add-on for OpenOffice Calc, which you can find on our website. There's a link to it here, the Solver for Nonlinear Programming. This is on the C21 Physics Teaching for the 21st Century website. And that links you to this page on openoffice.org. And this is the Solver for Nonlinear Programming, and get it. Click on this and install it into OpenOffice. After installing the add-on, you'll have this new item added to the tool menu called Solver. So we'll choose that. And what our job here is going to be is we're going to minimize the total chi-square. So we're going to optimize the result to get a minimum in cell E34. So we'll choose that. And we're going to create a minimum by changing the slope and the y-intercept of this best fit line, this green line here. And that slope and y-intercept are in these cells, J3 and J4. And now click on Solve. And we'll watch the spreadsheet adjust the slope and y-intercept here. And the green line bounces around until it converges on what it thinks is the closest fit to the data. So you can see here the results of the solver. It thinks that the slope is 9.73 meters per second squared and that the initial velocity is 1.13. Let's compare these results with the results of the built-in trendline function that comes with OpenOffice Calc. I'll double-click on the graph and ever so carefully choose the data series and select, we're right-clicking there and selecting Insert Trendline. It'll be a linear trend line because it's a straight line. We'll get it to show the equation and click OK. And there we go. It also thinks that the slope is 9.73 and that the y-intercept is 1.13. So behind the scenes, this trendline function is doing something very similar to what we're doing with the chi-squared analysis. This trendline serves as a good confirmation that we must be doing something right with the chi-squared business. Let's compare the pros and cons of using the chi-squared analysis versus using the built-in trendline function for fitting data. One of the pros of the built-in trendline is that it's fast, and some of the cons are that it will fit only linear, logarithmic, exponential, or power functions. As you can see in this menu, only those 4 types of functions appear here. So there's no sine functions and no periodic functions. So chi-square, however, can fit any type of function. And by the way, it's worth noticing that neither of these approaches can choose the function for you. You have to have some physical basis from your understanding of the problem at hand in order to choose the function. No spreadsheet will ever be able to do that for you. If you don't know what function to use, and you started trying one and then the next one and then the other until you found one that looks like it fits the data, you could have meaningless results. And this could be an example of data mining. This is what stock traders who use technical analysis sometimes do. They'll find a function that fits stock price data and use it to extrapolate future prices. And unless they have a physical or underlying basis for their function choice, it could be meaningless data mining. Another problem with the built-in trendline is that it assumes each data point has the same error. As this example down here shows, you have 2 different lines fitting this set of data. You have the green line and the red line. And the question is, which one is better, and which one would be given to you by the built-in trendline or the chi-squared analysis? The built-in trendline is more likely to give you something like the red line here, because it assumes all the data points have the same error, and this red line goes through every single error bar, and you might be mistaken in thinking the red line is the better fit. However, these 2 points at the end have less error, and so it's more important to get close to them than it is to get close to these first data points, because if these guys are so reliable, your fit had better weight them more heavily. So the chi-square analysis is more likely to give you this fit like the green line shows, and that is the better fit to this data. The pros in favor of the chi-squared analysis are that it can fit any function, and we're going to demonstrate quickly later how it can fit a periodic function. It can handle kinks in data, and I have a picture illustrating that here. This is a graph of the temperature difference between a cup, initially hot cup, and that's hotter than its environment, and its temperature decreases quickly and then slows to this point where it stops cooling, and this is a phase change there. Perhaps that's changing into ice, and then afterwards it starts cooling quickly again. So there's really 3 functions, 1, 2, and 3, that make up this single graph. And chi-squared is capable of handling that. You could even parameterize the domain of each function. If you don't know exactly where this change is between exponential cooling versus horizontal latent heat of cooling, you can make that a parameter in your fit as well. You could also use chi-square to fit only part of this data. This has been a tutorial on using chi-square to fit data using a spreadsheet. If you'd like to see us fit a periodic function using chi-square, stay tuned for video 4.2.